Students, we're going to go through section 3.3. Corresponding parts of congruent figures are congruent. You'll see this, so you'll see that as a T. That's congruent. Triangles are congruent, or you'll see it as F. So you'll see it both ways. What it says is if the whole thing's congruent, then all the parts will be equal as well. So if I look at here, ABC equals DEF, then I know that angle A equals angle D, that angle B is equal to angle E, and angle C is equal to angle F. We could also say that AB, side ABC, or AB will equal DE. So that's what we're going through. Is in a triangle, there's 6 parts, 3 angles, 3 sides, and they would all be congruent. So as we go through this next part, first part's pretty straightforward. Okay, DE is congruent. So if I look at DE, it's congruent to AB. They're the first 2 letters. So I come here. We want to know what is DE. So DE is this side here. And we know that it's congruent to AB. So it would be 2.6. Angle B. So then I look at angle B is equal to angle E. So I always look. So E and B are congruent. So if E is 65 degrees, then B is 65. I go FE. So FE, this side right here, and again, I go up to the letters. The letters are what helps us. So if I look at FE, that's right there. I know it's equal to CB down here. So that would be 3.7. And then lastly, angle C. I look up angle C and angle F are in the same spot. So C and F. So it'd be 42 degrees. I want to go through that because like this one here can get a little bit like if I look at WV, a lot of students will just look at it and say, okay, what corresponds to WV? Okay, and they'll say, well, WV, and they'll look and see. And sometimes it's backwards as you look at it. So I just go WV is right here as equal to ST. So I go ST and put that as 16. So, or I come here SU. SU is right here. SU. So this side corresponds to VX. VX, so that's 43. So I just want to show you guys that as you go through it. Use those letters to help you out. So next we're going to use 3 properties as we work through it. So just keep these in mind. Reflexive property, symmetric property, and transitive property. You'll see us use this one quite a bit, or not, I should say quite a bit, but a couple times today. So now we want to solve for the length. Okay, so again, I go to AB. AB corresponds to DE. So AB and DE are right here. And I don't know the length, so I set an equation to solve for x. So 3x plus 8 equals 5x. And I draw my line and I solve. Once I solve for it, we're going to get x is equal to 4. Or excuse me, x is equal to 4. There we go. Now, that's not what we're trying to solve for. What we're trying to solve is AB. So I'd plug it in to what AB is. So I go 3 times 4 plus 8. 3 times 4 is 12. 12 plus 8 is 20. So AB would be 20 inches. Same thing with angle D. So angle D corresponds to angle A. So I know A is 5y plus 11. And D is 6y plus 2. And so now we solve for it. So we'd subtract 5y, cancels off, 11 equals 1y, or you could just say y. Subtract 2, and so 9 is equal to y. So y is 2. Again, that's not what we want to find out. We want to know the measure of angle D. So we go 6 times 9 plus 2. 6 times 9 is 54, plus 2 is 56. So I'd say that's 56 degrees. So pay attention. If they ask you just to solve for x or y, then you'd be done. EF. EF is right here. It corresponds to BC. So EF corresponds to BC right there. And so it'd be 25 inches. Lastly, going through some proofs. So what we want to do is prove. Anytime you start with a proof, our first step is just writing what's our given. So we'd say triangle ABD is congruent to triangle ACD, and that's because it's given. So a couple things to then we want to prove. We want to prove that D is the midpoint. So this right here is the midpoint. To be midpoint means I need to know that this side is congruent to this side. Well, we just said that the triangles are congruent. Then if the triangles are congruent, then I know the parts are going to be congruent. So I know that BD, right there in that triangle, is going to equal CD. And so we'd say that BD is congruent to CD, and that's by CPC. And this, you could put FC or TC. F is for figures, corresponding parts of congruent figures are congruent, or TC would be triangles. All right, so now I just showed that these are congruent. Well, okay, now so we know D is the midpoint of BC. Okay, and you could say because we know that BD is congruent to DC. So we could say by definition of midpoint, midpoint means to be in the middle. D is the midpoint. All right. This one here, we again start out with your given. So it says quadrilateral JKLM is congruent to triangle NPQR. That would be given to us. Next, they say angle J is equal to angle K. Again, that's given to us. Then they say, all right, angle K is equal to angle P. Well, I know K is equal to P because of CPCFC. All right, and so then this, if you look at it, see how you have this K? K connects them both. J is equal to K and K is equal to P. Therefore, J and P are congruent. This would be the transitive property. So we'll go through two more proofs. I just want to point out to you, it says that ST, this line right here, bisects angle VSW. So that means that this angle right here is congruent to this angle here. So we'll start off with our given triangle SVT is congruent to triangle SWT because it's given to us. What we need to show is that this angle and this angle are congruent in order for them to be a bisector. So we'd say angle VST is congruent to angle WST, and that would be by CPCFC. We just said the whole triangle is congruent, so then the parts are equal. So then we know that ST bisects angle VSW by definition of angle bisector. So to bisect it means to cut into parts, to two equal parts. We know that those are congruent because the whole triangles are congruent. So that would be our proof. Last one. Again, a couple things I always like to show is so it says the whole thing's congruent, so that means all the corresponding parts are congruent. It also says that AD is equal to BC. Okay, so we're going to go through and say, okay, triangle ABCD, not triangle, but quadrilateral is congruent to quadrilateral EFG and H because it's given to us. I also know that AD is congruent to CD because it's given to us. All right. Now, what our goal is to get is that AD equals GH. Okay. So we want this side to equal this side. Well, we know that these two sides correspond. They're in the same position, CD and GH. So we could say that CD is congruent to GH by C, P, C, T, or F, C. So again, if you look at it now, see how this and this connected? So now we know that these two are congruent. So we'd say AD is congruent to GH, and that would be by the transitive property. So we introduce proofs today, start working through those. It's a great way for us to work on giving reasons for why things work out, not just based upon how